did the first 5 questions, so.
All right. I'm going to do roll in a minute maybe. I don't got time for it right now. So let me dive in. So they're asking, questions off the screen a little bit. Let me write it down for you. It's saying, is F strictly increasing on the interval -2, 0? That's their question.
It says decreasing.
Say decreasing? Oh, you're right. It does say decreasing. Whoops. Oh, I saw the wrong words. Okay, strictly. It does say strictly. Strictly decreasing on the interval. Okay. Now, first issue that happens for a lot of people. The -2, 0 can be confusing. Is that, you might look at that and go, is that a point? Is that like back 2 up 0, like right there, that point? No. It's an interval. How do you know? It looks like a point. Exactly. It's not the best notation on math's part. It'd be nice if they'd come up with a different way to say points than they do intervals. They didn't. We're stuck with it. So that could, in certain contexts, that could be a point. A lot of times it is. But here it's an interval. How do you know? Just like I said, context. You just have to read. They're saying the word interval. What I mean is, this is left edge, right edge, not over and up on the x. They're both x's. It's an interval on the x-axis. It's not the point back 2 up 0. It's on the x-axis from back 2 to over 0, which means it's from here to there on the graph. So first off, we got to speak their language and know what they're even saying. In fact, that's like 99% of the battle. I think the question is simple once you know what they're even saying. Does that make sense? So you have to know. It's bad notation on math's part, but we're stuck with it. You got to realize when you look at two numbers with a comma in the parenthesis, that can mean a dot on the graph, back 2 up 0. You know it could mean, whoops, I'm bumping the thing. It could mean that dot right there, that's the back 2 up 0 dot, or it can mean all the numbers on the x-axis from -2 to 0, like a domain or something, left edge, right edge. That's what it means here, because they're saying interval. Interval means only x's, only on the x-axis. So they're saying the x values from x -2 to x 0, which is this point, x value -2, to that point, x value 0. They mean this chunk of the graph, don't they? So what they're asking then is, hey, is that chunk of the graph going down?
Yes.
Well, yeah. Why don't they just say it in English? It's a simple question. Yes, next question. Does that make sense? You see, are you speaking their language there? Mm-hmm. So you always got to distinguish when you look at something with the two numbers with the comma. Is it a point or is it a chunk on the x-axis? When they say interval, it's a chunk on the x-axis, like domain, left edge, right edge. All right. Okay, so number 5 here. So they're saying list the places where it has the x values, where it has a local max. That'd be here and here first off, right? Maximum, peak, top. So it's just saying, and those are called local maximum because in their locality they're the top. I don't know what else the graph does. I mean, the graph may go up, up, up after that and there be higher points. This might not be the overall maximum. I don't know. It doesn't look. It looks like it's just a sine curve going up and down, up and down. But anyway, it's for sure a local max. In his vicinity, he's the biggest, right? Same thing with him. These are both what we call local max. Anyway, they just want the x values. I've scribbled it. I can't tell now. Looks like the x value is 4. And what's that one? -12. So they just want you to say 4 and -12. Those are the x values for those guys. That's all they want on that. That make sense? It's the x values for the local maxes. Oh, so to give them the actual points, the max points, they want you to say, what's the coordinates of that point? Well, that's over 4 up, is it 15? 16. Looks like it's 6. I don't know if you can see it. It looks like it's 16. You'll be able to tell on the graph when you do the homework. And this one's back 12, also 16, huh? So they just want you to turn those into a couple of points with a comma. That's part B on that. So that'll be easy. I'm going to flash off that, if that's okay. Nope, wrong one. There we go. All right, so this is number 6. We're in section 2. What are we in? 2.3, right? Mm-hmm. 2.3. Okay, so they're going to ask for the domain first off. What's the domain? Domain of a graph is left edge, right edge. You know that. So what's the left edge? What's the right edge of this graph? -3 to +3. Brackets or parentheses?
Brackets.
Because it hits them straight on, right? These are solid dots. Straight on the -3, +3. What's the range? Remember, so domain is left edge, right edge. Range is bottom, top, isn't it? Right? It's vertical span. Range is this way. So what's the range? Turn it sideways there, range. So what's the bottom? 0. The top is, I can't tell. 3, looks like 3, yeah. It's like right here, 3, 0 to 3. It's the range, okay. Now, intercepts. They ask for the intercepts. So those are all the points where the graph hits the grid lines, right? So that would be here, here, and here. All those points, it hits one of the grid lines. So, did I do the broad thing there? Yeah, I'm not even looking what I'm writing. 0 to 3. Yeah, sorry, thanks. All right, intercepts are back 1 up 0, over 0 up 1, over 1 up 0. Good? Those 3 dots. Back 1 up 0, over 0 up 1, over 1 up 0. So I want you to list them with commas. Next thing it says, is there any symmetry?
Yes, across the Y.
Yeah, the y-axis. It's the same both sides of the y-axis. The y-axis is like a mirror. So we'd say y-axis symmetry. And then the final question is it says list the intervals where it's increasing. So I think it says increasing, doesn't it? Just a minute. There it is. Okay, is that one even or odd or neither? So it's neither. Right? It doesn't have. It's not the same. If it came up like this instead of there, then that would be y-axis. That'd be even. Right? It's not. It doesn't do that. It's not the same on the two sides of the y-axis. It's not odd. For odd, it would need to. Here's the origin way down here. It would need to be, across the origin. It needed to be 2 quadrants away. It's not. So it's neither. On that good? I don't even know what number. This is number 7. So what's the domain's easy. Domain is left edge, right edge. So that's just -infinity, +infinity, right? Goes forever left, forever up and right. But the range is a little more interesting. What's the range on that function? It looks like, unless I'm mistaken, it looks like it's leveling out here. Mm-hmm. So that's at 8. Is that up at 8? It's up at 8. So it looked like it's going, remember range is bottom, comma top. It looks like it's going from a bottom of 8 to a top of infinity. And it's parentheses on both. Because it never, whoops, what just happened there? It never quite makes it to the 8, does it? Everybody see that? It never quite, it's like a plane that never quite lands. It never makes it to 8. So that's why I put a parenthesis here and not a bracket, because it never touches the 8. Does that make sense? On that? Does that seem weird that you could never, notice it gets closer to 8 forever without touching it. Is that possible?
Yeah.
Can you get closer to something forever without touching it? Yeah, I could do it with numbers pretty easy. I could say there's 8, no, that is 8. 8 and a half, then 8 and a third. Isn't that closer to 8? It's lower. And 8 and a fourth, 8 and a fifth. You get the idea. I could do that forever. Those numbers are getting closer and closer to 8 straight on, right? 8 and a fifth is lower than 8 and a fourth, right? But it's never touching 8. That's kind of like what it's doing, right? There's ways. Calculus talks all about that kind of thing, that infinite approaching. Okay. All right, so take a look at that one. What do y'all think of that one? Let's talk about, can I just go straight to the important stuff? How about, is it even, odd, or neither? Odd. Yeah, we all good with the fact that it's odd. Because if you rotate that 2 quadrants away, that's like the one I just held up. That's odd. That's what's it called? Origin symmetry. So it's an odd function. Good? All right. Okay. So f of x equals negative 5x squared minus 3x. Is it even, odd, or neither? So have you noticed the way this chapter is going, chapter 2, back and forth? They're giving us pictures all the time and saying, hey, what's the domain, what's the range, what's the symmetry or whatever, even, odd, whatever. For pictures, that's what we just did a few problems on, right? They gave us pictures. I held up pictures and we talked about even, odd, and stuff like that. And then they shift to equations, no picture. They want us to fly the plane blind now by the instruments. That's pretty much what they're doing. They're saying, all right, now you can't look out the window, you can't look at the picture. Just from the instruments, can you tell if it's even, odd, neither? What's the domain? What's the range? Right? So those are the 2 skills they're trying to build up. Your ability to deal with a picture, and then your ability to deal with an equation when you can't see a picture. What are the rules there? Well, I need to give you those rules. So to test for even, odd, the even, odd test for an equation, or a function or whatever, when there's no picture, basically, what do? First, plug in negative x for x and simplify. The simplified version is going to be called the new. I'll call it the new one. So you plug in negative. Here's how you use the equation. No picture to look at. Here's how you use the equation to figure out if it has even, odd, some kind of symmetry. You plug in negative x. You simplify it. I'm going to be calling that new. And then you just do a couple checks. It's even if the simplified new one. So, yeah. So if the simplified new one equals the original. Okay, and then it's odd. It's odd if the simplified new equals negative 1 times the original. So that's A, B, and then C. Otherwise, if it doesn't do either one of those, otherwise it's neither. Otherwise it's neither. Oops. Is that making sense then? So let's do it on this one. So let's try the plug-in thing. So I'm going to take the function they gave me right here, and I'm going to plug in negative x everywhere we've got x. Kind of running out of room there. Equals. So there's negative x plugged in. Kind of running out of room. So what happens to, when you simplify, what happens to negative x squared? Yeah, it just becomes x squared. Huh? That negative vanishes, right? Negative squared is positive. The negative on the 5 doesn't go anywhere, but the negative x squared just becomes regular x squared because negative squared is positive, right? 2 negatives is positive. And then negative times negative, negative 3 times negative x, positive. We good there? So this is the new. And our question is, how does the new compare to the original? And so basically what they're saying, if they're exactly the same, right, if the simplified new equals the original, that'd be even. If they're completely the opposite, negative 1, right, all the signs, when you multiply something by negative 1, all the signs change, right? Not just some of the signs, right? So that's what they're asking. Is it completely the same, or is it totally the opposite, or is it somewhere in between? If that's the case, that's neither. So are they totally the same? Is the original totally the same as the new? No, that plus 3x minus 3x part is different. So it's not even. Are they totally the opposite? If you took negative 1 times, if I took negative 1 times that original, what would I get? It would go boom, boom. I'd get plus 5x squared plus 3x. Is that what I got here? No, not quite. I got a negative 5x squared. I got part different, part the same. So ours is neither. It's neither odd nor even. It's neither x-axis nor y-axis. I mean, it's neither y-axis nor origin symmetry. Question? Yeah.
So if it's odd, you just plug in -1 to the equation?
Oh, no, that was a test. Yeah, so good question. Let me clarify a little bit. So these are tests. So the only plugging in I do is I plug in negative x, like I did right here. So I plug in the negative x, and then I simplify, and then I just simply check it. I just compare the new one to the original, and I say, are they exactly the same? Are all the signs exactly the same? If so, that means it's even. If simplified new one equals the original, then it's even. But if instead it's the simplified new one is -1 times the original, meaning all the signs are the opposite. Right? If I take -1 times the original, do I get the new one? If that's the case, that's odd. Otherwise, it's neither. We good on that? Okay, so there we go. So g of x equals 8x squared minus 5. So even, odd, or neither. So what do? You plug in negative x. And simplify. So what is that? That's just 8x squared minus 5, right? So that's the new. Up here's the original. So you ask yourself, are they totally the same, or are they totally, they're totally the same. So what does that mean?
Even.
Even. They're the same. So that means it's an even function. Is that good? Questions on that? Now, I haven't given you any reasons for that. Like, why would plugging in negative x and simplifying it and it comes out the same, why would that mean even? What is even again? Y-axis symmetry, right? Why would that mean, if an equation does that, why would that mean graphically that it's got y-axis symmetry? Well, think about it for a second. If you have a graph like x squared, for example, whoops, that wasn't very good. I'm not an artist. I don't know if you've noticed. All right, so if you have a graph like that, if you go over somewhere to the right, any amount, call it positive x, and go up, and you go back that same amount, plugging in negative x, what height are you going to get? Same height, same y. Remember, g of x is y. G of x is y. When you plug in negative x or regular x, you get the same y. You get the whole thing being the same. That's what it means to have y-axis symmetry. You go right or left, and you go up, you get the y value. Remember, y value is the whole function. They're equal. Same height. That's what it means. So we've got, let's call it y. Y equals cube root of 7x. So what do? Plug in negative x. Simplify. You can't really simplify. There's nothing much you can do. I mean, you can make it. There's nothing to do. So, yeah. Oh no. I see. This one's a little tricky. Yeah. Okay. Yeah. So. Actually, we can simplify. Yeah, actually, we can simplify. My mistake. Well, let's simplify. How do we simplify that? Well, can you make that negative 7? Yeah, positive times negative is negative 7x. Good. Now, here's the real question. Well, let's leave it at that. Okay, there we go. So I simplified it. Okay, now the question is it even, first off? If it's even, these guys are the same. No, they're clearly not the same. They're not the same. So it's not even. But is it odd? Is it odd? Well, it's odd if what? What's the test for oddness? -1 times either one. Basically, it doesn't matter which one. Just take one of them, multiply by -1. Do you get the other one? That's basically what you're asking, right? -1 times whatever. I'll just do the original. Right, this one. Does that equal that one? This is supposed to be times here. Right? Shouldn't bring in another x when we've got an x. Anyway, so there we go. -1 times the one of them. Does it equal the other one? Well, what do you think? Can you do -1 times that and not sneak it inside the root like that? Yeah, for odd it does. It's true. Think about it. Real life. This is what I would do. You know, the way I learn things like this is not because I just have a head full of encyclopedia knowledge, or I did when I was a student either. I have a terrible memory. I always kid my wife. She remembers everything in the world perfectly. And we've been married a long time now, 26 years next month, and she'll remember some thing we did on a trip, and she'll remember what we had for lunch and, you know, what we talked about. I'll be like, honey, I don't even remember the trip. You know, it's like you're already a widow. Your memories are your own. I always kid her. Anyway, I have a terrible memory. You don't do math science by a great memory. If I was looking at something like this, I was on a test, I was under pressure, is that true or false? I would test it. That's if you can learn to do that as a math science person. That's not just me. That's what all math science people. I would look at that and I go, I'm not trying to search my memory for some little fact. You can't memorize everything in math science. Instead, you have to think, let me make up an example. Let me just put a negative in a cube root, do something easy that I can handle, and see what happens with that negative. What is the cube root of negative 8? Negative 8.
Negative 2.
Yeah, negative 2 times negative 2 times negative. So the answer to this is negative 2. Good? True? Now, the question we're asking is that the same as just putting the negative on the outside? Well, okay, a negative on the outside is just a negative, and what's the cube root of 8? They are the same. See that? Negative inside, negative outside, same answer. That's the kind of thing you need to do for yourself. That's how you gain in the math science world. You can't memorize all the little facts, but you need to learn to be a critical thinker that way on testing things yourself. Just make up number examples to figure out the rules. Does that make sense? So I look down here and go, oh yeah, negative on the outside, negative on the inside, yes sirree, Bob. That's the same. That's the same. It's odd. Make sense? Okay, by the way, if that was an even root, that would not be the same, would it? It's all about the fact that that's odd. Because odd number of negative signs make negative. 3 negatives make negative. If you gave the square root of, like, whatever, negative 16 or whatever, what's that? What's the 2 root of negative 16? It's imaginary. It's not negative 4 times negative 4. That'd be positive 16. You can't do it at all. You can't do the even root of negatives, but you can do the odd. Because an odd amount of negatives can be negative, right? Does that make sense? That what we just did is what you need to be doing for yourself. Hour upon hour upon hour. That's what people don't do who try to go to calculus and don't make it. Really, that's it. It's all, you got to get all that down. It's all this picky little, that's what you got to do. You got to spend time thinking on all that. And that takes hours. That tells stories. I can't be doing that. I'm going to get distracted. All right, so f of x equals 6x plus absolute value 6x. All right, plug it in. We're doing the test. Plug it in. Like that. Okay, simplify it, right? Let's simplify it. So this would be, positive times negative is just negative. Good. Positive times negative is just negative. What about the absolute value thing? What does absolute value do to negatives? Bye-bye, right? It makes it positive. It's gonzo, right? But the other one stays. So the question is, how does this compare to the original? Are they the same?
No.
No, not even. Are all the signs, if I take one of them, say like take the first one, whatever, doesn't matter which one, and I multiply the whole thing by negative 1, boom, boom, get negative 6x minus absolute value 6. Does that make it the same as the other one? Not quite, no. That negative outside the absolute value, I can't get rid of that. It's just the ones inside you can get rid of. No, it's not odd either. It's neither. You all see that? Right? When you plug in negative x, see the problem is when one of them is different and not the other. That's when it's neither, huh? If they're both the opposite, that's odd. If they're both the same, that's even. You seeing that? Right? So when I plug in negative x and get rid of it, negatives inside absolute value go away, but the other one stays. This is not the same as the original, but it's not completely the opposite either. They're not both opposite signs from the original, so it's neither. All right, so let's plug in negative x. like that. Good to there so far. I plugged in negative x. Okay, and then simplify, right? Simplify it. So negative times negative is positive, and this negative squared just goes away, right? Okay, so how does that compare to the original? So first off, are they the same? Is it even and the same? No, clearly not the same. Right, you with me? Not the same. Is it odd? Meaning if you take negative 1 times the original, right, this is the original. If you take negative 1 times the original, do you get that one? What does a negative do when it hits a fraction? Does it go to both? It just goes to one of them, right? When you have a negative on a fraction, remember, you put it on the top only, or you put it on the bottom, but you can't put it on both, because 2 negatives would be positive. That can't be right. You got to be crystal clear on that rule. You can't be struggling to have a grip on that rule. That rule's got to be in your fist and never moved, because it's going to come up a lot, like right here. So that negative, you can go to the top only or the bottom. If I put to the top, I get exactly that other one. Yes. Odd. That make sense on that? So remember, a negative on a fraction only goes to one side or the other. That one, I remember that on some test in the past, like half the class getting fooled by that, or more than half, because they were a little rusty on what a negative does on a fraction. So I'm kind of making a big deal out of that. Does that make sense? We all good on that? That won't happen to you guys now, right? I don't even know if it's on the test. I don't even remember, but it was on one of my tests one year. All right, good on that? So that one is odd. Okay, yeah, so there's the function. Put that into y1. X squared. All right, put that into y1, and then you graph it, you know. They're telling you the window, by the way, which is very helpful. See the x and the y? That's the window. Everybody see that? This is x min, x max, y min, y max. Everybody seeing that? So make your window, set your window like they have it. Graph the thing, and then we have to find the minimums and the maximums. I'll just write the steps here to find a min or a max. On the TI, I'm always given TI instructions, so I'll need to send you Casio ones for those that have Casio. Casio's usually very easy to use. I just don't know it. What do? You hit second calc something. Second calc. Doesn't matter. Oh, thanks. Oh, you got a Casio? You know how to do it?
Yeah, I did it.
And how do you get the max min on the Casio? Do you know? Oh, it's probably just the solver, huh? Oh yeah, and then the max. Oh, that's beautiful. Yeah, the Casio is easier to use. I don't know why the TI is dominating the market. That's nice. That's easier. We got to do a lot more on the TI. That's beautiful. Yeah. So hits for the TI, you hit second calc, and then isn't there like a max option or something? There's like a max or a min. There's a min and a max. So just choose whatever you're trying to find. And then you got to do the whole left of it, enter. See, the TI is more work. Right of it, enter. And then on it, enter. You know what I mean by that? Let me show you something. Yeah, can I see the graph again one more time? And I'll just draw it, and then I'll write those instructions. Thank you. So you put that in. It's so it ends. It must be A. It's off the screen. It's not this one. Wait, or is it? Oh, it is that one. And that's on the screen. Yes. Let me just do that. Okay. So I don't need that. I've got it. Thank you. It is C. So it's this one. Okay. So now let's find them one at a time. You ready? Let's find this. This is a min, right? A minimum value, a local min. They want you to find that. So how do you find it? You hit second calc, and you choose min. And then it basically going to do just like it did for some of the other things. It wants you to start with a point left of that, a point right of that, and then do your best to get close to on that for your guess. It calls it guess. Left of it, right of it, guess, boom, and you hit it, and you should get your answer. What's the answer to that one? Somebody got that?
Well, -4 and -22.
Wait, kind of see, did you have it on your?
Right. I put the minimum on there.
Oh, yeah, so yeah, -4,
And
yeah.
-20.4.
Yeah, looks good. -4, -20.4. Did you all get that?
So you have to shift close to that one point and then click enter to get
Shift G solve.
Well, that's for the Casio. They're all have TI.
Oh,
Yeah, yeah. So you gotta go left of it, right of it, on it. So whenever you want to find a minimum value, you gotta go left of it, right of it, on it. That's what it wants you to do. You guys getting that to happen? Can I use your calculator? And I'll just throw it up here on the screen real quick. So we've got the function in there. To graph it. The window looks good. Oops, I'm not on the Elmo. Right, and so there it is. So you go to second calc, go down to, I'll start by finding the minimum. We're going to have to do each one separately. Go to the minimum, hit enter. Now, see the flashing cursor right here? It's saying left bound. It wants you to go left of that spot. So I'll move. It doesn't matter how far left, just somewhere left. You're just giving the TI calculator a zone to search in, going from here to there. So I got to go left of it. That's good enough. Enter. Then it says, okay, now go right of it for me. Casio's a lot easier than this. And the Casio's like $60. These things are like $100. Go right of it, enter. And then go. I should become a Casio salesman. I'm naturally a Casio salesman. And go on the guess there and hit enter. And there it is. -3.999. Yeah, you know what that is? That's the fact that the calculator's not very smart. That's -4. It's just calculators just plug in numbers real fast, so that's the closest it could get. It's really Casio did a little bit better job there. -4.
Yeah, I was saying I got -4.
Did yours? So whatever. This one's rounding somehow, not rounding very well.
I think it's because you chose 1 point lower than the other. When you put in the second number, it was a little bit lower than the first one you put in.
I don't think it matters where I started, but maybe. So anyway, so is that good? Everybody good on that? That makes sense how to do it. Then you got to redo it to find that other one, that max up there. Do it again, get second calc, go down to maximum now. And it says, okay, you want to go left of it, so we're talking about that one right there. So I just got to put some dot left of it. Let me get a little closer here. So good enough right there, that's left of it, enter. Now it says, go right of it for me. So I move my cursor over there. So right there is the tip, but I'm going to go right of it, giving it a zone, enter. Now it says, okay, now go on it. Give me a guess where it's at. It's about right there, that's where it starts looking. Boom, there we go. It finds out 1.666 in the Y value. Like that. Was that all good? How that works? Go back to the... thank you. Okay, so that's finding maximum. Oh, and they want an interval, I think, too, don't they? So what were those spots? Again, this one was like -4 on the x-axis, right? And this, what was this one here? I just did it, but I forget it. 1.6, that's right, 1.67 or whatever it was, rounded to the two places, okay? So notice the graph now. The final places, the final question is they're going to say intervals where it's increasing. So what are the intervals where it's increasing? From here to there. That's increasing. So that would be from -4 to positive 1.67 or whatever it was, rounded to however far they want you to round it. Parentheses again, no brackets. They always want parentheses on x intervals. And what are the intervals in which it's decreasing? Well, decreasing would be this section and this section. And that would be from -6, because remember our x min is -6. To negative. They don't want negative infinity. They just want in your window. So that'd be from -6 to -4, it's decreasing. And from 1.6 to, what's the right edge? 4? To +4, so the 1.67 or whatever it is, if they wanted rounded to two places, I think that would be it. I don't know how many they wanted rounded. 1.67 to 4. Does that make sense on that for the increasing and decreasing intervals? You had to put a comma between those. I'm going to do in 30 seconds, and I want to go back into that other one. So 24 says, here's some function. Find the minimum on your graphing utility. So that means y1 equals graph minimum. That's all they want you to do. It's all just graphing calculator button pushing for number 24. Does that make sense? Just enter that into y1, graph it, find the minimum like we just did. Like we just found the minimum on that one. So 21. So f of x equals minus 3x squared plus 5. They're going to ask you a few questions. Average rate of change. They're getting you ready for calculus. Rate of change is something you do in calculus all the time. It's a fancy way to say slope. Average rate of change is slope. Remember the slope function formula? y2 minus y1 over x2 minus x1. Remember that? But instead of y2 and y1, what is y values? It's f. Remember y values are f values? F of x2 minus f of x1. Yeah, so what you'll really use is f of x2 minus f of x1 over x2 minus x1. So it's the slope formula, but instead of the y's, we have a function. So it's f of x2 and f of x1. That is y2, y1. So what do we mean? Well, here it is. For part A, they're saying -1 to +1. So this is x1, this is x2. So what you do is you say f of 1 minus f of -1 over 1 minus -1. Is that too quick? See what I did there? That's this right there, isn't it? x2 goes there, x1 goes there. Everybody see that? And so what is f of 1? Well, here's the function. Plug into that function. There is the function. Minus 3 times 1 squared plus 5 minus, and then f of -1 is minus 3 times -1 squared plus 5 all over 1 minus -1. Everybody see that? Everybody good with that? This is f of 1. This is f of -1, isn't it? And then you just work out the numbers. That's what you do on all those average rate of change. It's slope. Rate of change is slope. All right. Thanks, guys. We finished 2-3, didn't we? 2-3 will be due on Monday. Have a good weekend. I'll see you on Monday. Hang out if you got questions. Otherwise, see you Monday.